happens is that they created some of these things and there are a whole lot of data and they are a much more coercive society. So they can force all the data to be there. We will still be arguing in the Supreme Court whether you can have other data or not. And I am not for data privacy, so I am not on coercive use of data. But I think I will use this occasion to re-emphasize a couple of points about this before, by the time Kapil would have recovered his breath. You see, one of the problems with, what should I say, this pursuit of data is that people ignore its meaningfulness. One of the big issues in both big data analytics and AI is the interpretability of the data. Now that on a computer says this, therefore you must believe it. I think this is another important one. That's why the word data scientist started to be used, that you are understanding something about what happens. There is also an expression to a Nobel laureate in economics that if you torture data enough, it will confess. What is the meaning? The meaning is it will confess to the relationships between data points which look erratic.
And doing that.
Torturing. Exactly. So that is a very, so this is
you have decided the result and
I think this is very important to understand. So let me say, I mentioned about this, that the big problem with humans is they don't appreciate the exponential function. In natural life we don't see it. The most exponential growth happens actually when the child is in the womb. And then for the first 6 months or so, after that we square him down to linear growth. Class 1, class 2, class 3, class 4 and so on. So we don't see with our eyes exponential growth anywhere, and sometimes that change becomes this thing. But you look at mathematics, everything begins small. So y is equal to x is the starting point of almost all things that happen. But if that function is going to be part of sine x, then you know what is going to happen. You will increase like this, then go down, then go negative, then come up and so on. Now, looking at the first few set of data, no matter how many data points are, if it is the initial stage of the phenomenon, you will not. At the most you will see, okay, some x square kind of thing at it. But that, after a while, is going to go down. Or is it going to go up like e to the power x? Or is it going to remain linear for 70 years or 200 years or 500 years? Or it is going to be a polynomial. Now this is what I am trying to say, that this is the thing that we need to understand. And eventually, we like it or not, it's the math that prevails. And one of the big things about maths is the distinction between the kinetics and the dynamics. Kinetics is you are observing what is happening, but unless you understand what are the forces that are leading to that, what is the reason for that behavior, causal, it could be human, mechanical, physical, electrical, biological, whatever, you will never know. And your biggest disappointment will be if you run into something which is like going like tan x. So it will go like this, go almost infinity, and then go to minus infinity and then start there, and then you will wonder what happened. That's another example of disruption. So this is the big thing that is happening in AI and machine learning. Do you try to understand the answer as well, or do you say this is an answer given by AI and therefore we accept? For a long time, this was so, even today lots of companies advertise they are using AI, they are actually using just a search engine. They are not using AI as a learning algorithm, but they say that. Now with the GDPR in Europe, you are now going to have to explain to your customer what were the principles of the algorithm which gave that result. So for a loan, or this, a healthcare, insurance, etc., you just can't say computer says this, you have to shell that out. You have to say what is this that you put into the algorithms. And that is becoming very important. And I am especially interested in this because when the Maruti allocation first happened, there were people who were disappointed because they didn't get their numbers, and I was party to a writ petition in the Allahabad High Court where we challenged whether this random number allocation is aligned to Article 14 of the Constitution. Now you can imagine the challenge, and because these people were judges who were not very good in maths or science, they found the escape route of something else, so they never really answered. But this will question more and more. Is any algorithm that is being used, in the data set that is being used, violative of your constitutional guarantees? And I'll give an example, it's well known in this thing. There was a conference happening in Atlanta, Georgia, where people had gone, and there were some black people. When they went to the washroom, the automatic soap dispenser did not work. He called another black person, then he called a white person, it worked. And they started saying that here is racial discrimination even in the automated soap dispenser. And when this was taken further, it was found that it is the purchasing which was a problem, because they bought a very low-cost dispenser which did not really have that level of sensitivity to measure the light reflected. And so when they changed that, this was true. So this question will start being asked. It will no longer be treated as a black box which you can't add. They will want to know what are these things, what was the, like in software, what is the testing that you did, what is the thing that you did, all these things will become very, very important. It's a very exciting field to be in because it covers so many other things. It's also almost the beginning of a new field. It has, for those people who have some background of science, it's like the early days of electricity and magnetism when we were talking about Faraday's laws and Maxwell's equations and so on and so forth. We are in that stage and a lot more is going to happen. So now with this, we'll have couple come up and speak very briefly. We'll like to take a break at about 11:30.
So I'll see you.